Hello and welcome to Math200 Statistics online here at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 7.2. This is problem number 1. It says here that the average time to run a 5K fun run is 25 minutes and the standard deviation is 2.6 minutes. 40 runners are randomly selected to run the 5K fun run. Round all answers to 4 decimal places where possible and assume a normal distribution. So we can assume that we have a normal distribution and we're given some information. So let's make a note of the information. In our original distribution, we have the mean to be 25 minutes and our standard deviation to be 2.6 minutes, and we have 40 runners, so let's call that n. All right, so they're asking for the distribution, the original x distribution, and the original x distribution is going to be this distribution that was given to us. And remember, for the notation for the normal distribution, the first number is the mean. So that would be 25. The next number is the standard deviation, 2.6, and that's all. All right, now if we switch distributions to the mean distribution. So here is our mean distribution here, x bar. So what is x bar going to look like? Remember, for the mean distribution, this is mu sub x bar, and that's going to be 25. It's going to be the same distribution as the original distribution. The standard deviation, however, will not be the same, and this is going to be 2.6 divided by the square root of the n sample size that we're talking about. All right, while we're here, we can go to the next one where they're looking for the sum distribution. And we want to find the mean and standard deviation for that as well. So we will call this mu, and then we use the sigma x for the sum, and that is going to be the mu times n. So this is going to be 25 times 40. And then the sigma, the standard deviation of the sum distribution, that's sum, S-U-M, is going to be the original mean, or the original standard deviation, 2.6, and then instead of divided by 40, this is multiplied by the square root of 40. Okay, so those are going to be our values. Now, I think it might be a good idea to do this on, you can definitely do this on a calculator, but I think it's a good idea to take advantage of our Excel sheet or our Google Sheets sheet. And this is what I have so far. I have some spaces for the mean and the standard deviation for the original distribution. So the mean was 25. Yes, 25. And then the standard deviation was 2.6. Oh, and then we have a sample size of 40, so let's put 40 down here. And so I want to take advantage of the clicking the cells of things, and so let's take a look at the mean distribution. So the mean distribution is just going to be exactly the original mean mu. So I'll just say equals, and I'll click on the 25 where the mean mu is, and I'll press enter, and so that's also 25. Now the sigma, however, is going to be different. It's going to be this number 2.6 divided by the square root of 40. So here I will put equals, and I'll click on this 2.6, and divided by SQRT is the square root, and the value is 40 given here. And so it looks like the mean is going to be 0.4111, rounded off to 4 decimal places. Now the sum distribution, and the mean for the sum distribution is going to be the original mean, and I had put an equal sign here, so equals, I click on the original mean, times the standard, not the standard deviation, but the sample size. So that's going to be 1,000. And then the sigma is going to be equal to, I'll press equals, and the original standard deviation, and this time it's times the square root of 40, or the square root of the n size. Okay, so if you set up your sheet like this, then you can change the mean and the standard deviation and the sample size to adhere to any problem that you might have, and it'll automatically recalculate the mean distribution, the sum distribution, etc. So looking at this, it's 0.4111 for the standard deviation, and then 1,016.4438. So let's fill those in. We have the same mean here, 25. And then the standard deviation is 2.6 divided by 40, 2.6 divided by square root of 40, which we found to be 0.411. And then it says 0.96, so I'll round off to 1. Now the sum is 25 times 40. I think that ended up being 1,000. And then this 26, or 2.6 times square root of 40, ended up being 16.44384, so we'll just go to 38. All right. Off to our next question. Our next question is asking us if one person was randomly selected, if one randomly selected runner, let me underline, maybe even highlight this one. If one randomly selected runner is timed, find the probability that that runner will be between these two values. So on a calculator, this can fit in one command, but unfortunately in Google Sheets, we'll have to do a couple of commands for this. But which shouldn't be too bad. And in Google Sheets, I would press equals and then norm.dist, so that's normal distribution. And then I'll pick this larger size. This is 25.4833, comma. Now it's asking for the mean. And since this is referring to 1, this should be referring to the original distribution that has a mean of 25 and a standard deviation of 2.6. Now, we also want the cumulative toggle to be true. And then so that's going to take care of that first one. But if we're between two values, we have to find a value for the larger one and subtract the value for the smaller one. So that's norm.dist, and then the smaller value is 25.0833, and then the same mean, 25, the same standard deviation, 2.6, and then true again. And then that should give us our value. So let's do this, and let's see how quickly we can find this. This is going to be, in notation purposes, this is our probability that we're between 25.0833 less than x less than 4833. So 4833. So that's the notation that we want to put on, and then let's find the value. So the value, we'll say equals, and then norm.dist, and then the x value is 25.4833. That's the larger one. And then for the mean and standard deviation, I can click on the mean and standard deviation, but let's just say this is the mean, and I'll press comma, and then I'll click on the standard deviation, and then press comma, and then it's going to ask, is it cumulative? So we'll say true, and you get 5737, and that's it. So our value here would be 5737. Oh, sorry, this is only part of it. So I'm going to go ahead and copy this, or you can retype everything over again, but I'll copy that and I'll change this one number here. So this is 0. So 25.0833, and then the mean, and then the standard deviation. So now the value that we get is 0.0695. So I think that rounds off to 0.0610. So our value here is 0.0610. Okay. Next question. For 40 runners, find the probability that their average time is between these two values. So their average time, I will highlight that to say, hey, we are now shifting to a different distribution. And our distribution that we're looking at is going to be, let's use a slightly thicker pen. For this distribution, because of the average time, we would be looking at this distribution with a mean of 25 and a standard deviation of 4.111. It's going to be the same sort of command here, which makes me think I need to get my pen size to be a little smaller. So it'll be the same command. It's going to be between two values, so it's going to be norm.dist of something minus something else. So this first something is 25.4833, and then our mean is still 25 because we're at this distribution, but our standard deviation now is different. So it's that 26 divided by square root of 40, or you can just click on the 4.111. Now I would be a little wary about typing this in rounded off to 4 decimal places, because your probability might not round off accurately to 4 decimal places. So the more decimal places you can get, the better. And if you're relying on Google Sheets, you can just click on the actual cell that gives you the value. And then we have true to say yes, it is cumulative, and then we have to subtract off that other one, norm.dist, and this time it's 25.0833, and the same mean 25, and our standard deviation, remember, is 2.6. I think there should be a dot here, 2.6 divided by root 40, and then true. Okay, so let's find that in our Google Sheets. And this time it's almost the same thing, so I'm going to copy these values here, but instead of x in the middle here, it's actually the mean, so it's actually x bar, and I can't do my fancy math typing here, so I'll just type in the whole x bar, and then I'll put the work over here, and the work over here is almost the same as this. So I'm going to go ahead and copy that, and I shouldn't just copy the cells. I should probably go directly to this cell and then highlight this formula bar and then copy that. And then I'll go here to my new cell where I want my answer, and I will put my cursor on the formula bar again. I'll press paste. All right, so I have the same setup. Except my mean is the same, but my standard deviation is not the same already. Actually, just to be absolutely sure, I'm highlighting my mean right now, and I'm going to go ahead and click on this mean, although it's the same. Oops, that didn't work out yet. So let me highlight this, and instead of highlighting it, I'm going to delete it, and I'm going to click on this mean, which gives the same answer, but that's okay. I'm going to take this standard deviation out, and I'm going to click on this standard deviation. And so now that's my setup, and I have to do the same thing for the other computation here. So this mean, oops, disappeared again. So I have to delete it first, and then I'll click on this cell, which gives me the mean. And then I will take this old standard deviation, take that out, and click on my new standard deviation, which is this, and then it's true. All right. So that's my value. It's 0.29984. If I press enter, I'll see just that, 0.29984. So I think that's 0.2998. So we'll go with that as our answer. This is 0.2998. All right, we are in F. We're finding the probability that randomly selected 40-person team will have a total time more than this. So a couple of things to highlight here. First of all, the fact that we are looking at a 40-person team will have a total time. A 40-person team will have a total time means that we will actually want to use the sum distribution. So this is the sum distribution right here. So this has yet a different mean and a different standard deviation. There's one more thing in terms of this particular problem, one more thing to note, and that is we're looking for more than 104. So I didn't put the probabilities here, but I put it on my Google Sheets. But here we're looking for the probability that the sum distribution, so that's the sum, the sigma of x, is bigger than 1004. So remember, when we see this bigger than symbol over here, the normal distribution looks at the area to the left. So the bigger than, we're going to want the area to the left subtracted from the 100%. So the way I'm going to call on this in my Google Sheets is I'm going to say out of 100%, I want to take away the norm.dist of this value of 1004. And then now my mean is going to be the mean from the sum. So I can say 20 times 40 or 25 times 40, or I can just say 100 or 1000, sorry. And then the standard deviation is 2.6 times square root of 40, or 16.4438. And then cumulative again. Okay, so this is the command that I will put into my Google Sheets to be able to get my answer. So let's go ahead and get that going. And remember that this is P probability, and I'll put sum of x, sum of x bigger than 1004. And so how's that going to look like? We're going to say equals, and remember we start off with 100%. Because it's more than, we're going to subtract off the norm.dist, and then we will be looking for the mean for the sum distribution. The mean for the sum distribution is 1000. Oops, we want to put 1004 first. That's the x value that we have, and then the mean of the sum distribution is 1000, comma, space, and then the standard deviation is going to be 16.4438, or if I just click on that, I'll have a lot more accurate computation. and then true for this to be cumulative. So it looks like I get a value of 4039. Yep, that's rounded off to 4 decimal places. So 4039. That's 0.4039. Okay. All right, we are in part G. It's asking if assumption of normal is necessary according to the central limit theorem. It doesn't matter what kind of distribution you have when we're finding for a large value of n, when we're looking for the mean distribution or the sum distribution. It doesn't matter if the original distribution is normal or not. We're still going to be ending up with a normal distribution with those. All right, one more question. The top 20% of all 40-person relay races will compete in the championship round. These are the 20% lowest times. How or what is the longest total time that a relay team can have and still be able to make the championship round? So if we're talking about a relay team, we're talking about adding each individual person's time. So again, we will highlight this idea that we're looking for the total time, which will make us go back to the sum distribution again. So this H will refer back again to the sum distribution, which has this mean and this standard deviation. All right. The other thing to note for this particular problem is that we're given a percentile, a percentage or percentile, and we're looking for the lowest 40%. So if we were to draw a distribution, and this would be the sum distribution, where we found the mean to be 1,000 and the standard deviation to be, I think it was 16.44 or something like that. We want the lowest 20%. So this is 20%, and then this must be 80% here, but we're not going to care too much about that. So we will use our inverse norm distribution or inverse norm function to figure out what this value is. And so that percentile is going to be equals to norm.inv for inverse, and then we have the area to the left is 20%, so 0.20, and then the mean is coming from the sum distribution, which is 1,000, and the standard deviation I think was about 16.4438. And then that's it. So that should give us our value. And if we look at this value, it should be, you know, it's in the thousands, or the mean is in the thousands, so this would be less than 1,000 and probably be over 100 at least to be a few standard deviations. In fact, it's 16 point something, and so just imagine maybe subtracting 30 or no more than 60, so it should be in the 900 range is our anticipation. So let's go ahead and call on that. So this is going to be the 20th percentile for the sum distribution. All right, so in the 40th percentile, we will say equals norm.inv, and then we will have the value 20%, 0.20, and then the mean in this case will be our sum distribution mean, comma, and our standard deviation would be given here. And then we'll press enter, and we get 986.61605. So 986, which I think was the anticipated value about. So 986, 1605. 986.61605. 0.1605. And I think that's it. All right, so there's a lot going on here. This particular problem goes from the original distribution and then takes on the mean distribution and the sum distribution. And the key here is to read what it is they're asking for in the probability, decide which distribution to use, and then use that appropriately. All right. So that's the layout, and that's the layout for this problem, and I hope that helps. Good luck. I'll see you later.